Okay, so today we're talking about the different rules for differentiation, and you guys were so awesome. You already were able to come up with the rule for the power rule is what it's called. So basically, here's a couple of rules that we've already really talked about. One is called the constant rule, and this just says if we take the derivative of a constant, 5, remember we said the slope is 0. So anytime we take the derivative of a constant, the slope is going to be 0. Then we have the power rule, and we already talked about this, how this power goes down a degree, and so we have the derivative of 8x to the 4th, we would take 4 times 8, which is 32, and the power is 1 less, x to the 3rd. This is the same thing. Even if n is negative, we can still use the power rule. So the derivative of 4x to the negative 3 times 4 gives us negative 12, and then 1 less would be x to the negative 4. And then we have the constant multiple rule. I already showed you that. And the sum and difference rule. This just says if we have a bunch of numbers added together, subtracted, we can still use that power rule every time. So if you look at this, problem 1, problem 2, I want you to use the power rule to find those derivatives. Find dy dx for problem 1 and 2. That'll be part of the lesson check. Same thing with problem 3. This should say find dp dt if p is this. And then I want to go through problem 4 with you. Does the curve y equals x to the 4th minus 2x squared plus 2 have any horizontal tangents? And we've talked about this already, but again, what does it mean if I want a horizontal tangent? Remember, a horizontal line, m is 0. The slope is 0. And what's derivative? Slope. So for a horizontal tangent, we want dy dx to equal 0. So the first thing we have to do is take this equation and find dy dx. So dy dx equals 4, x to the 1 less, minus 4, x to the 1 less, plus 0. So we have 4x cubed minus 4x. We want dy dx to be 0, so we're going to substitute 0 for dy dx. Now we need to solve this. We're going to factor out of 4x and get x squared minus 1, and we still can factor x minus 1, x plus 1. So where will there be horizontal tangents? At x equals 0, 1, and negative 1. So yes, there are 3 horizontal tangents. At the point 0, x is 0. So if I put 0 in here, 0 minus 0 plus 2, at 0, 2. At 1, 1 minus 2 is negative 1, plus 2 is 1. And at negative 1, that would still be 1 minus 2 plus 2, so I get negative 1, 1. So there's 3 horizontal tangents at the point 0, 2, 1, 1, negative 1, 1. Please make sure you're jotting down any questions, comments that you have for me. Second and higher order derivatives. The derivative, or y prime dy dx, is called the first derivative of y with respect to x. We can also take the derivative of y prime, which gives us the second derivative, y double prime. This would be known as d squared y over dx squared. Remember, d dx means take the derivative of the derivative, so that's d squared dx squared, d squared y dx squared. After the third derivative, we can still use 3 primes, but anytime after 3, we just put it in parentheses and say, okay, the fourth derivative will be y to the 4th. So find all the derivatives. Well, y prime, the first derivative, would be 21 x squared minus 6x plus 17. The second derivative, double prime, 21 times 2, 42x minus 6. Third derivative would be 42. And the fourth and final derivative would be 0. So that's finding all derivatives of this function. Once you get to 0, you're done. Those are finding all the other derivatives. So we can find the second derivative, third derivative. Okay, here's where we have some new information that we have to go through. The product rule. I hope you realize that not all functions are going to be those equations, 2x squared plus 5x minus 3. We're going to have complex equations like problem 5. And problem 5 is way complex. We have this multiplication here. This is a product, hence the reason why we need the product rule. So this is saying if we have a product, to find the derivative, it's keep the first function times the derivative of the second function plus the second function times the derivative of the first. And I think if you just watch this example, I'll show you what I'm talking about. So this would be the first function, 2x squared minus 1. 5x plus 7 would be the second, 1 times 2. So the derivative, y prime, is 1 derivative of 2 plus 2 derivative of 1. 1d2 plus 2d1. 1d2 plus 2d1. You want to take some time and memorize that. 1d2 plus 2d1. And the d means take the derivative. So 1, keep it, the first function. Derivative of the second, 5, plus 1d2. 1, derivative of the second, plus 2, 5x plus 7, derivative of the first, 4x. Now we clean it up. 10x squared minus 5 plus 20x squared plus 28x. Clean it up. 30x squared plus 28x minus 5. That's using the product rule. So the product rule is 1d2 plus 2d1. First quantity times the derivative of the second plus second quantity times the derivative of the first. 1d2 plus 2d1. Take a minute and say that with me. 1d2 plus 2d1. It's going to be very important. So I would like you to try problem number 6 using the product rule. Try problem number 6 using the product rule. Now we have the quotient rule. Again, sometimes we're going to have derivatives where we have division. And the quotient rule says, in English, in a way that you can remember it, low d high minus high d low all over low squared. So in this problem, this quantity here is what we call low. Not low, high. The x would be the low. High function, low function. So I know we sound like a bunch of 7 dwarfs, but this is the same. Low d high minus high d low all over low squared. High d low, man, I keep messing up. Low d high minus high d low all over low squared. So let me take you through that. dy dx would be low times the derivative of high minus high d low, 1, all divided by low squared. Low d high minus high d low, all over low squared. Notice this long fraction bar, it's over everything. Now we clean it up. 3x cubed minus 2x minus x cubed plus 2x minus 5 all over low squared. So we get 4x cubed minus 5 all over x squared. And I'll show you something in class tomorrow that will help you, and we can do this another way to check our answer. We'll talk about that tomorrow in class. So I would like you to try the quotient rule on problem number 8, and we will come back to class on next week and talk about problem 9 and 10 that we have there. So problem 8 is part of your assignment. After that, you can stop with the notes. You can also visit www.calculushelp-help.com and go to the tutorials and watch the product rule and the quotient rule. Now I will tell you, their product rule, they kind of do it backwards. I think they do 2D1 plus 1D2, and that's okay, but we'll keep with our phrase that's in our book and how I've been teaching it for years. So if you want to watch those tutorials, there's a product rule and a quotient rule video that you can watch. There's some things in there though that we don't know, I think, but you'll still be able to kind of get the idea of what they're doing. Okay, after you get all of these notes done, that's your assignment for tonight. Make sure you come to class with questions. Make sure you do the lesson check as well as watching this video and doing these problems.